All right, guys. Today we'll be going through generate parentheses on LeetCode number 22, and that's a medium question. And apparently it's got a lot of likes. And the question is, given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So if you look at this, it's basically like a permutation problem. And the first idea was to use backtrack because backtrack basically is all about permutations. And they define well-formed parentheses is basically you need to have 3 open and 3 closed parentheses, and but you cannot have something like this. You cannot have an open and then close and open parentheses. This is not a valid solution. And so let's do just a code walkthrough and see if it makes sense. All right, so basically for all backtracking problems, you always have a base case. So what's our base case would be? So the base case would just be, the length of our answer has to be equal to n times 2, right? Because n is 3 means we have 3 parentheses, but times 2 has 6 characters within the string. So I'll define a function called backtrack. I'm going to leave the parameters empty right now. And basically, we're going to have an array. I'm going to call it answer array. And it's going to be empty. And we're going to call backtrack with whatever, things we want to pass in. So the first thing we definitely need to pass in, it got to be a path, right? So that way, we can just append this to our answer array at the end. And we also need to keep track of how many open parentheses we have as well as closing parentheses. So we're going to have open. We just put 0 for open and 0 for close because we're starting fresh and there's nothing there. So basically, there will be a path and open parentheses. Open P stands for open parentheses, and then close P is the closing parentheses, right? And at the end, we just want to return our answer array. Okay, so but base case, like I said earlier, is basically the length of the path if this is equal to our n times 2, right? So if this is the case, we want to do answer array dot append with our path, and then we just return. Okay, so here's our logic for backtracking the rest, coming up with different permutations. So if the open parentheses is less than n, that means we can keep adding more open parentheses to it. So we're going to call backtrack with path plus open. And then since we're adding 1 to it, we have to increment our parameter open p plus 1. And then close p stay the same because we didn't change anything. And then for the second logic would be if close p is less than open p. And the reason why we're using close p less than open p rather than close p less than n is because we want to make sure we don't have anything like this happen, right? This is not a valid well-formed parentheses. So this ensures us that we don't have more than open parentheses. Okay, so if close p is less than open p, all we have to do is just call backtrack with path plus a closing parentheses, and then open p stay the same, and then close p it's going to be plus 1, and that's it. So let's submit. Oops, oh, got an error. Open p is not defined. Oh, Submit. There we go. Pass.